This is the solutions video for the addition rule on probability worksheet. For the first section, we're asked to determine if these are mutually exclusive. So mutually exclusive means two things cannot occur simultaneously, cannot occur at the same time. Whatever. All right, cannot occur simultaneously. So think about, in all these questions, could this thing and this thing happen at the same time? If they could not happen exactly at the same time, you would say it's mutually exclusive. If they could happen at the same time, you would say not mutually exclusive. All right, so let's look at the first one. Being a U.S. Senator and a member of the U.S. House of Representatives at the same time, that cannot occur. You can't run for a Senate position and a House Rep position. No one could do that. You could do them at different times, but not at the same time. So you would say these are, yes, mutually exclusive. Winning first prize and winning second prize in a spelling contest. Well, you can't enter twice and win first and second. Those cannot occur at the same time, so that would also be mutually exclusive. Let's say ME. The New York Yankees and the New York Mets both winning the same World Series. Well, that can't happen. There's only one winner of the World Series, so those would be mutually exclusive. Being pregnant and giving birth to twins and triplets. Could you do that at the same time? That's a good question. Maybe this is medically possible. This one, I guess you could theoretically answer either. But giving birth to twins and triplets at the same time, I guess that would be the same as kind of giving birth to 5. I don't think that's possible. So that would be mutually exclusive. Being a registered Democrat and a registered Republican, you cannot register as both. It's one or the other. So I would say that is mutually exclusive as well. So actually, none of these are not mutually exclusive, whatever that's worth. All right. You could make an argument for D, but again, whatever. All right. And these next problems, we're going to use the same formula in all of these. Probability of either, the formula that I'm giving you, so either A or B, is the probability of A plus the probability of B minus the probability of both. The probability of this happening plus the probability of this happening, but there's an overlap, so we subtract out the overlap. So in the first one, I'm not going to read all of these, but you want to know the probability that a student reads either magazine. So it's 63% read the first magazine plus 51% read the second magazine. 24% read both, so we're going to subtract out that 24%. So it's a pretty simple formula here. You do this one plus this one minus the overlap that both of them read. It's 24, so that gives us 90%. So 90% chance that a student reads either the Time magazine or U.S. News and World Report. Probably kind of outdated at this point. Probably more better study would maybe use, I don't know, Instagram or TikTok or both. Right. Okay, next one. 90% of calls for emergency service on a cold winter day for cars that won't start because of dead battery. 10% no gas for our cars have both a dead battery and no gas. That would be kind of hard at the same time, but I guess if you ran out of gas and then you left your battery on, I guess you could get both. So probability they won't start because of dead battery or no gas. So that's going to be the probability of either. So really what we're saying is probability of dead battery or no gas. It's a good idea to write it out. That's going to be 90% for dead battery plus 10% for no gas. Now, if you just left it at that, that would be 100%. That's not true. You could have, accident or something, right? And so we're minusing out that 4%, which would be 96%. So a lot. All right. 4, we're asking the probability that it will be Macon Expressway, we'll get the contract, or Seaview Expressway, And then probability that both be awarded contracts is 20.22. So probability that it will be awarded make-in or C-view. So make-in or C-view would be 0.65 plus 0.43 minus 0.22. So the first several are laid out really nicely for you. This is 0.86. All right, next one, probability that either a man or his wife is a college graduate. Probability that a man is 0.35. Probability of the wife is 0.41. And the probability of both is 0.14. So subtract that out. And we get 62, 162. Number 6. This one is just a tad bit confusing because what it does is it gives you the probability of a breakdown. So this is the probability of commuter bus breaking down, and the probability of commuter train breaking down is 0.07. Probability that both will break down is 0.02. So on the surface, you would think the probability of either breakdown, right? So that would be 0.12 plus 0.07 minus 0.02, and that's going to give you 0.17. So this is the probability of either breaking down, but the question asks the problem of no breakdowns. So if this is the probability of either breaking downs, then the probability of neither, really that's what it's asking, right? Probability of no breakdowns is really the probability of neither. To define that, you just take the overall probability, which is 1, and you minus 0.17. So that's 0.83. For the next two, it's going to be just rearranging a little bit. We did like this on the Edpuzzle video, where it actually gives you sort of a different part of the formula, and then you got to solve for it. All right, so in this it says 74% have either. So it's giving you the probability of either, and it's asking you to find the probability of both. So we're still using this formula of probability of either equals probability of A plus probability of B minus probability of both, except we're going to be solving for the both part of this. So the probability of either was 74%. So it's like 74% equals dog probability is 50% plus cat is 38%. And then it's minus the probability of both. And that's what we're trying to find. So what I would do is you just kind of like switch the probability of both and the 74%. If you add the probability of both over to the left side and subtract the minus 74, kind of do it in 2 steps here. 74%, and then we would add this over. 74% plus probability of both equals 50 plus 38 would be 88%. And then we would just subtract that 74%. So probability of both would be 88 minus 74, which would be 14%. So the probability of some random house in Morganville having both a dog and a cat would be 14%. The next one works the same way. Probability of a man buying both flowers and jewelry. So it gives us the probability of either. It says 58% will buy, 71%, will buy either. So 71% equals 58 are going to buy jewelry. 39 buy flowers, plus 39, minus the probability of both, because that's what we're asked. So solve it the same way, you add the probability of both over and then subtract the 71. We get, really ends up being just probability of both equals 58 plus 39 minus 71. Just kind of switch it around. So when we do that, 58 plus 39 minus 71 equals 26%. that a wife buys both flowers and jewelry for their birthday. All right, now the last one is an either again. So back to what we were doing before, but there's just there's a few things mixed into here. So let's write this out. Probability of either jog or swim or cycle. So it's going to work similar. We're going to do probability of jog plus probability of swim plus probability of cycle. And now for the both, let's see what information it gives us. Technically, we could be subtracting out probability of both would be jog and swim, or jog and cycle, or swim and cycle. So let's see what it tells us. So we got jog, swim, cycle, minus the probability of, so 18 jog and swim. So minus the probability of jog and swim, minus 15% swim and cycle, so that's both. And then minus 17 jog and cycle, it's the probability of jog and cycle. And then 7 jog, swim, and cycle, so they do all three. So these are all the overlaps. So our formula is going to end up being this: 53% jog, plus 44% that swim, plus 46% that cycle, minus 18% that jog and swim, minus 15 swim and cycle, minus 18 jog and cycle, and 7 jog, swim, and cycle. These are the three events. Have you ever heard of a triathlon before? Triathlon is running, swimming, and cycling. You actually swim first, and then you ride the bike, you cycle, and then you jog, is the order of the triathlon. So let's get this: 53 plus 44 plus 46 plus, or sorry, minus 18 minus 15 minus 17 minus 7. That would be 86% of Americans do one of these three: jogging, swimming, or cycling. All right, that does it, folks. Let me know if you have any questions.